Today, we're talking about some of the reasons why you would want to join parts in post and not print it as one piece. I'm David Godwin, the head of creative at Carbon. And today, to help me answer some of those questions, is Garrett Fielding, a formulation technician at Carbon. Garrett, thanks for joining me today on Ask an Additive Expert.
Thanks for having me.
So, Garrett, tell me why you would want to print a part in components and then assemble in post. Some of the reasons.
The two biggest reasons are, first of all, your part might not fit in the build volume. So that's the obvious case. The other less obvious reason would be that your part is too complex or has too many fine features to be printed in a single print process.
Have you printed things like this that meet either criteria? What are some examples of that?
Sure. One example of too many features would be the OpenRC F1 project that I started. So it's a scale RC car that's a model of an F1 car. And for anyone who's ever seen a Formula One race car, it is a highly geometrically complex shape. The other part of this, obviously, is this also has moving parts. There are tires that need to rotate. There are axles that need to spin. There needs to be free range of motion. And allowing that range of motion is always easier when assembling a part rather than trying to print it in a single piece.
So what types of connections did you use for the RC car?
For the RC car project, the obvious answer is fasteners. So because of its need to be disassembled and reassembled, fasteners, nuts, bolts, screws, mechanical fastening is an excellent choice because it provides a strong bond. You're using actual metal hardware, so you're going to get a good mechanical connection, but it is disassemblable.
Does Carbon have any sort of advantage when using fasteners like that?
Carbon's resins, in particular the EPX family, has a very low degree of creep, which means that it will retain its shape over time despite a load being applied on it. So with the RC car, I needed a rigid material. I needed something that could handle a great degree of stress. It is an RC car after all. And so I chose EPX specifically because I knew that it was rigid, it was strong, and the fasteners that I would be applying would not deform the part over time.
So what's another method for joining parts in post?
If the part needs to simply look the part, you're subjecting it to a very low degree of stress. Cyanoacrylate or CA glue is a very common approach, but it is fairly brittle. And if you subject it to large forces, it can come apart. So if your part's just for display or light use, CA glue is a good option. For heavier applications, epoxy is a commonly used adhesive. Two-part epoxies tend to be very strong, very durable. They are slightly more flexible. They can be slightly more flexible than, say, a CA glue.
So like when you're making a wizard staff, you're definitely going to want to use an epoxy, right?
Absolutely. If you're making a large, heavy part, something that might need to be spun around or carried around at a convention or something like that, absolutely, yes, epoxy would be the way to go.
It seems really like a crazy design challenge to kind of build these in multiple components and line them up and getting all of the joints to match. What's a good method for that?
So when designing large assemblies in particular, you need to have registration marks or other alignment methods to make sure that your parts, first of all, line up together, and then second of all, stay aligned. So a simple way to do this is a pin and hole registration, where one part has a protruding pin, another part has a receiving hole, and as those two parts come together, those line up and will maintain their location relative to each other. First of all, you know that your parts actually will have the fit and finish that you want in the end because you can line these parts up as you're assembling. But second of all, it gives the parts a more rigid mechanical fixture as the adhesive is setting up.
I'd imagine that registration marks and whatnot require a pretty high degree of printing accuracy.
The accuracy of your registration is completely dependent on the accuracy of your printer. Carbon's platform has a high degree of accuracy, which allows for tighter, more precise joints. So the tighter tolerances you can have on your joints mean the stronger that joint will be, the less reliant you are on the adhesive itself, and you are putting a greater degree of confidence in the part and the material.
Hey, Garrett, thanks for answering all these questions and providing some cool tips and tricks for how to join parts in post and why you would want to do something like that. For more tips and tricks and conversations with Additive Experts, tune into Carbon on YouTube or visit us online at carbon3d.com. Again, Garrett, hey, thanks so much. That was awesome.
Thanks.